This is the review for the multiple choice component of the Chapter 12 test on sequences and series. So one of the things we talked about in Chapter 12 was how to use the graphing calculator to find something like this. The sum from j equals 7 to 20 of j squared times 1 plus j. Now, what you can do, if you want to do it the long way, is you can start by plugging in 7, and then add that to the answer you get when you plug in 8, and then add that to the answer you get when you plug in 9, and keep going until you've plugged in 20, and then you add all those terms together. The problem was that took a lot of work. So instead of doing that, what we wanted to do was use a graphing calculator to do it. So if you go to second stat, that's where we're going to find our functions that will sum this for us. And I like to call this program that we use sum sequence. So you go to second stat, and then you go to math, and you hit number 5, which is sum. And then you go back into second stat again, but this time you only arrow to ops, and you hit number 5, which is sequence. And now on the front of your, hold on, I just screwed mine up. Let's see, delete, second stat, ops, number 5. So on your screen, you're going to see sum sequence. Now, once you get to this, if you have one of the new operating systems on the calculator, you probably now have this list that says like equation, variable, start, end, and I think the last one is like increments, but I don't remember how it does it because the calculator I'm currently using has an old operating system. If you have a calculator with the old operating system, like the one I have in my hand, the first thing that you're going to do is you're going to type in the equation. And in our case, we're going to put in x squared 1 plus x. X squared 1 plus x. And then you're going to put in a comma. After you put in the equation, you type in the variable and you hit comma. The next thing you do is you type in the starting value that you want to plug in. And in our case, it was 7. Then we type in the ending value, which in our case was 20. And the last thing you do is you type the increment, which is always going to be 1 for us, and then you close the parentheses. And then after I hit enter, I find out the answer is 46,438. The next thing we talked about was arithmetic sequences. We did a couple things with them. We wrote equations for finding the nth term. We found some term down the road. We found the sum of a certain number of terms in an arithmetic sequence. Remember that I will give you the formulas for all of these equations. There are a lot of them. It's hard to remember them. What I'm not going to tell you is what they're for. So if I wanted to write an equation for the nth term of this sequence, the nth term is the first term plus n minus 1 times the common difference. In this case, it would be 25 plus n minus 1 times the common difference. It's going up by 1.5 each time. You can leave the equation like this, or you can simplify it by distributing and then combining like terms, in which case, let's see, 23.5 plus 1.5n. So now, if I wanted to find the 10th term in this sequence, I would plug in 10 for n. And I would get 38.5. What if I wanted to find the sum of the first 10 terms? Well, the sum of a certain number of terms in an arithmetic sequence is n divided by 2 times the first term plus n minus 1 times the common difference. But there's another formula you can use if you know the last term in the sequence. So if you happen to know the 10th term, you could just add the first term and the last term. Now, it doesn't make any difference which one we do here. Let's say we didn't find the 10th term, and we want to find the sum of the first 10 terms, then I would use this one. Or if I found the nth term first, I would use this one. So it would be 10 divided by 2. The first term was 25, plus the 10th term was 38.5. And the sum would be 317.5. After arithmetic sequences, we talked about geometric sequences. We did several things with them. We had a formula for finding the nth term. It was a sub 1 times the common ratio raised to the n minus 1 power, where the common ratio was found by taking the second term and dividing it by the first term, or the third divided by the second, or the fourth divided by the third, or so on. So if I wanted to know the formula for the nth term of this particular geometric sequence, I would write a sub n is equal to 1 times the common ratio is 1/3 to the n minus 1. So if I wanted to know the 10th term, I would just raise this to the 10 minus 1 power, which is actually the 9th power. So basically I would just do 1/3 raised to the 9th power. And it gives me something nasty, and my calculator won't even turn it into a fraction at this point in time. But that's fine. I probably wouldn't want to find anything that big anyway. It would basically 1/3 to the 9th, whatever 3 to the 9th is. It's some big number. Let's see, what does my calculator say? 19,683. So it's really 1/19,683. What if I wanted to find the sum of the first 10 terms? Well, the formula for finding the sum of the first 10 terms is the first term times r to the n minus 1 over r minus 1. So in this case, the first term was 1, and then the common ratio was 1/3 to the 10th minus 1 over 1/3 minus 1. And in this case, I would evaluate this first. I would do parentheses 1/3 raised to the 10th, and then I would subtract 1 from it, and then I would take that answer and divide it by the quantity of 1/3 minus 1, and I would probably put that in parentheses too. And then I'd multiply it by 1 before I found out the answer was just like 1.4999974597, or about 1.5. But this sequence is not finite, it's infinite. And as long as we have an infinite sequence that is convergent, not divergent, that means the numbers are getting smaller and probably closer to 0 rather than bigger and bigger, we have a formula for finding the sum of an infinite geometric series. So what if I wanted to find the sum of the whole series? Well, in this case, it would be the first term divided by 1 minus the common ratio, which in this case is going to be 1.5 or 3/2. After that, we talked about using this Tvm Solver, and there are different things we do. We can either add money to an account, take money out of an account. We could talk about mortgage payments, car payments. Let's say that the monthly payment on a 30-year mortgage is $100,000 at 8% interest per year, compounded monthly. That means you're paying 12 times a year. What's going to be the total amount paid on this loan over the 30-year period? So you have to ask yourself, what are you actually finding? In the Tvm Solver, the first thing is n, and n is the number of total payments you're going to make. You make monthly payments for 30 years. So that's 12 times a year for 30 years, which is 360 payments. I is always the interest, and you don't turn it into a decimal, you just leave it as a percent. PV is like your previous value. If you're buying a car or buying a house, PV is always the price of the house or the car. If instead you were putting money into an account and saving money, PV would always start with 0. PMT is your monthly payments. And a lot of times with cars and mortgages, we don't know what that is yet, and that's what we're going to solve for. FV, your future value. If you're paying something off, you want your future value to be 0. If you're putting money into an account for many years, you're going to want to find what the future value is. And payments per year, in this case, is 12. So then you would get your cursor up here to PMT. And do second, or not second, but alpha solve, and I'll tell you the answer is $733.76. And don't forget, when you're dealing with money, to round to the nearest cent. Don't round it up to the nearest dollar. Mortgage companies don't do that. The last thing that we're going to talk about is finding a term in a binomial expansion, particularly in an expansion that we are not going to make we're not going to extend Pascal's triangle to find. So if I want to find the fifth term in the expansion of AB minus 1 to the 20th power, I do not want to expand Pascal's triangle to the 20th row to figure out the fifth terms. However, what I can do is I can figure out what the coefficient is going to be. You figure out the coefficient by using a combination. And the first number in the combination is the power to which the binomial is being raised, so it's 20. Well, the next thing is, what's the fifth term? Well, I want you to think about the pattern of which this works. So, you know the first term is going to be AB to the 20th. The second term is going to be AB to the 19th. The second term is going to be AB to the 18th. So, in order to figure this out, the way that Pascal's triangle works is the first term is always the first coefficient is always 1, and that's because it's being raised to the 0 power. So the first coefficient would be found, the first coefficient would be found by doing 20, 0. The next coefficient would be found by doing 21. The next coefficient would be found by doing 22. So the second number in the combination is always 1 less than the term you're looking for. So if I'm looking for the fifth term, this is going to be 5 minus 1, or 4. So I'm going to find the coefficient by doing 20 NCR 4 in my calculator. As for the other two terms, which are AB and -1, since I'm going down in powers, the second, this is the AB is going to have an exponent of 20 minus 4, which is 16, which means this has to be 4. So now in my calculator, I'm going to do my 20 NCR 4. And I got to type it in right. 20 NCR 4, which is 4,845. And then it's going to be a to the 16th, b to the 16th. And remember, when you raise -1 to the 4th power, it's +1. So this would be the final answer. This problem is a little bit different than if I had asked you to find the term with the x to the 4th in it in the expansion of x plus 2y to the 10th. To find the term with x to the 4th in it, we had this other formula for finding it. Where r would be 4, n would be 10. So in this case, your coefficient would be found by doing 10 and 6, because it's n minus r. And then the first term would be raised to the r power, because remember, we want x to the 4th anyway. And the second term would be raised to the 6th power, because I want those two exponents to add up to 10. So notice how these two problems are different, where this one asked me to find the fifth term. So in order to find the coefficient, I did 20 NCR, the term I'm looking for, minus 1. In this one, I used this little formula. And then you would have whatever the, 10, NCR 6 is 210, times x to the 4th times 2 to the 6th is 64, y to the 6th, so then you would do 210 times 64, which is 13,440, x to the 4th, y to the 6th. And that is what is going to be on the multiple choice portion of the Chapter 12 test.